Good morning guys. Welcome to Mind Your Math. Today our class is on polynomials. Now before moving ahead with the concept of this particular topic, let us check the prerequisite knowledge that you should already be having before you start the class. You should be knowing about algebraic expressions. You should know about the basic operations as an addition, subtraction, multiplication, etc. of algebraic expressions. You should know the identities. These three identities, it is a plus b the whole square, a minus b the whole square, and a square minus b square, and basic factorization of algebraic expressions using these identities. Now, if you are clear about all these three concepts, let us move on with polynomials. Okay. Now let us see what a polynomial is. Is polynomial an algebraic expression, or polynomial is totally different from an algebraic expression? And what are the necessary terms that are associated with this particular chapter? Okay. I have written 4 algebraic expressions here. X square minus 3x, root x plus 3, x1 by x plus s, and this. Now, how many of these are polynomials? You know, all these 4 are algebraic expressions. How many of these are polynomials? So, I would say this and the last one are polynomials, but these 2 are not. Why? In the first case and the last one, which are identified as polynomials, the power of the variable or the exponent to which the variable is raised is a whole number. Here it is a 2 and here x is raised to a 1. Here it is a 3, here x is raised to a 1 and here x is raised to a 0. Okay. In these 2 cases, root x plus 3 is actually x raised to 1 by 2 plus 3. The power is not a whole number, it's a fraction. Here I have, the power is not a whole number, it is an integer. Okay. So, what are polynomials? Polynomials are basically algebraic expressions. But all algebraic expressions are not polynomials. Only those algebraic expressions where the variable is raised to a whole number is a polynomial. So, I can easily say this and these are polynomials and these are not. Okay. Suppose I have a polynomial x raised to 5 plus x raised to 1 by 3 plus 9. Is this a polynomial? It is very clearly not a polynomial because though the power of x is raised to a whole number 5 here, in the second case it is raised to a power of 1 by 3 and therefore it is not a polynomial. Okay. So now you know how to identify a polynomial from any algebraic expression that is given to you. So that is our first step, that is identification. Now the second one. What are called as the terms of the polynomial? Now you can see that. So I will just erase what are not polynomials. Now that the identification of the polynomials is over, let us move on. The next is something called as the terms of the polynomial. Now you have a polynomial x square minus 3x, and if somebody asks you what are the terms of this particular polynomial, they would be x square and minus 3x. What are the terms of this polynomial? It would be x cube, 4x and 5. So what do you mean by the terms of a polynomial? They are the parts of the polynomial along with their signs. In this case, I cannot neglect the negative sign when I am taking the second part. So, the terms of the polynomial would be x square and minus 3x. I write another polynomial x raised to 7 minus 7x raised to 8 plus 9 minus 10x. It's a random polynomial. What are the terms of this polynomial? X raised to 7 minus 7x raised to 8, 9 and minus 10. Okay. So that is the second concept, the terms of the polynomial. Okay. Now, what is the third? The degree of the polynomial. Now, let us see what a degree of the polynomial means. You know that in a polynomial, the variable is raised to a whole number. Okay. So, any polynomial will have different values of exponents. So in this case, I have got a 3 as an exponent. I have got 1 as an exponent. Here I have got a 0 as an exponent. Here I have got 7 as an exponent, 8 as an exponent, 0 as an exponent, and 1 as an exponent. It is x raised to 1, that is the exponent. Here I have got 2 and here I have got 1. So what do you mean by degree? Degree is the highest power to which the polynomial is raised. So in this case, 2 is the degree of the polynomial. Okay. In this case, what is the degree of the polynomial? It is not a 7, it is an 8 because the second term is the one which has got the highest power. Similarly, for the third one, you can see that the degree of the polynomial is a 3. Okay. Now we are done with the concept of degree of the polynomial. Let us move on to the next one, which is the coefficient. I have written a random polynomial here, x raised to 7 plus 3x raised to 5 plus 9x minus 10. Okay. How many terms are there? This polynomial has got 4 terms. 1, 2, 3, 4. Okay. Which are those? X raised to 7, 3x raised to 5, 9x and a minus 10. What is the degree of the polynomial? It's the highest power to which if the variable is raised in the polynomial. So I can see it is an x raised to 7. So my degree of the polynomial is a 7. Let us move on to the concept of coefficient. Each term of the polynomial has coefficient. Coefficient is the value of the integer scaled with the variable. So x raised to 7. What is the integer next to x raised to 7? It is a 1. It cannot be a 0 because then the x raised to 7 will not exist. 1 x raised to 7. In the second case, what is the coefficient? It is a plus 3. In the third case, what is the coefficient? It is a plus 9. What about the fourth case? Do you find a variable there? You can see that it is a minus 10 over there. There is a variable which is raised to a power of 0. What is x raised to 0? Any value raised to 0 is a 1, except 0 raised to 0. So, what is the coefficient of the term x raised to 0? It is a minus 10. I hope I have been pretty clear about explaining about the coefficient. Like we can look at one more example. So 7x raised to 5 minus 9x cube plus 1 by 5. Okay. This is a polynomial. 3 terms. 7x raised to 5 minus 9x raised to 3 and 1 by 5. Degree of the polynomial is a 5. What is the coefficient of the term containing x raised to 3? This term, the coefficient is a minus 9. What is the degree of the term containing x raised to 0? So when you look at it, you can see that x raised to 0 means a 1. That is a constant thing. So it is 1 by 5. Okay. Now we have already cleared the concept of degree and the coefficient. Let us see the number 5. It's a random number, it's a constant. Is it a polynomial? Yes, it is a polynomial. What is the degree of this particular polynomial? Now this particular polynomial, as when we look at it, we cannot see any variable standing along with it. But we know that there is an x raised to 0 over there. What is the degree of this polynomial? The degree of this particular polynomial is a 0. Okay. This kind of polynomials are called as constant polynomials. So, any number that you take, 1 by 5, 7, 100, 1000, all these are polynomials whose degree is a 0 and they are called as constant polynomials. Okay? Okay. We have a number which is a 0, right? That is a constant polynomial according to our definition. But the 0 is a special number in the sense that when we put a 0, suppose you have a polynomial 3x square plus 5x. You don't see a 0 over there, right? Any other constant, suppose if it was a 7 or an 8 or 100 or 1000 or any fraction over there, we would have put it over there. In this case, we don't put the 0 over there. This particular constant 0 is a special case of constant polynomial which is called as a 0 polynomial. See, just like in the case of exponent, 0 raised to 0 is not defined. In the case of division, 1 by 0 or any number by 0 is not defined. We say it is an infinity, it's a concept, all those things. Similarly, in this case also, 0 polynomial has no degree. The degree of a 0 polynomial is not defined. Okay? Okay. Now, I have explained about constant polynomial and a special case of constant polynomial called as a 0 polynomial. Now, let us see the names of polynomial or how a polynomial is mentioned based on the number of terms. So you already know how to identify the terms of a polynomial. Suppose I have a polynomial x square. This is a polynomial, right? The degree of the polynomial is a 2. Now, how many terms are there? There is only one term. A polynomial with only one term is called as a monomial. So, polynomial with 2 terms will be called as a binomial. Polynomial with 3 terms is called as a trinomial. So, what do you call a polynomial with 4 terms? See, normally beyond the power of 3, we normally term the polynomials. We mentioned like polynomials with 4 terms, polynomials with 5 terms, and so on and so forth. In rare cases, polynomial with 4 terms are also called as quadrinomials. But more easier to say, I have a polynomial with 4 terms. Okay. So that was our next concept. It was the classification of the polynomials based on the number of terms. So I will just put it over here itself. Terms and classification based on it. Okay, fine. Now let us move on to the next concept. Okay, now we know what the degree of a polynomial is. Based on the degree of a polynomial, we have classification of polynomials. Okay. Suppose I have a polynomial x minus 3. You know that it is a binomial. The degree of the binomial here is a 1 because the power of the highest power of the variable is a 1. The polynomials with degree 1 are called as linear polynomials. Like how we have studied linear equations, linear expressions and all those things. Now, when the power is a 2, it is called as a quadratic. Power is a 3, you have a cubic polynomial, and power is a 4, you have a biquadratic, and so on. Now, the linear polynomial is something that you're already familiar with it while doing linear equations in the previous year. Quadratic is something that you will study more in this year and in the next year also, and also cubic. Okay, and the more concept-wise clarity of the polynomials you will get as and when we proceed with this chapter. Okay, fine. So now we so far have in this class we have gone through the identification of a polynomial, how to identify polynomial from any algebraic expression, the terms of a polynomial, and how to classify a polynomial as a monomial, binomial, trinomial, etc. based on the number of terms. We know what is the degree of a polynomial and the classification based on the degree as a linear, quadratic, cubic, etc. We know about the concept of coefficient of a polynomial, and based on that we know what a constant polynomial is and a special case of constant polynomial called as a 0 polynomial. And you know that we can represent a polynomial by px, qx, rx, etc. Okay. Now let us move on to the concept of zeros or the roots of a polynomial. So, zeros of a polynomial. They are also called as the roots. Suppose I have a polynomial f of x. I am writing the polynomial as x square minus 4. So, let us just brush through the previous topics once again. How many terms? 2 terms, x square and minus 4. What is the degree of the polynomial? Degree of the polynomial is a 2. What is the coefficient of the highest degree term? It is a 1. Okay, clear? And this is a binomial and it is a quadratic polynomial. Okay. Now, f of 1 here, f of x is x square minus 4. So in terms of x, in the place of x I have written 1. So in the polynomial also, in the place of x I have to put 1. 1 square minus 4. That is a 1 minus 4, it's a minus. F of 0. 0 square minus 4, it is a minus. F of 2. 2 square minus 4, 0. F of 100. 100 square minus 4. 6. F of minus 2. So basically, whatever we substitute in the value or the place of x, we get a particular value for the polynomial, right? As long as we are substituting a constant value in the place of x, we get a value for the polynomial. Can I do this for this polynomial? I can do this. Wherever x is there, I can write. It becomes z square minus 4. Okay. When f of 1, when I am putting 1 in the place of x, I get a minus 3. Here I get a minus 4. When I am putting a 2 over there, I get a 0. When I am putting a minus 2 also, I get a 0. The values of x, which will finally give the value of the polynomial as a 0, is called as the root of the polynomial or the 0 of the polynomial. Okay. Suppose, what do I write as a polynomial? X minus 3, I have a polynomial. What is the root of this polynomial? It is very clearly, if I am putting h of 3, it becomes 3 minus 3, which is a 0. So I can say that 3 is the root of this polynomial. Okay. I have a polynomial p of x is equal to x square minus x plus 1. Okay. And they are asking you to find p of 1 and p of 2. How will you find it? P of 1 will be equal to, wherever x is there, I will substitute 1. I will get 1. P of 2 will be 2 square minus 2 plus 1. 4 minus 2 plus 1, 3. Okay. So, when the value of x is given to you, you can find out the corresponding value of the polynomial. Okay. Fine. Now, I have given another polynomial and they are asking you to find the value of the polynomial at 1, 2, 3 and 10. And they are asking you to decide from these numbers which is the 0 of the polynomial. Okay. I would first find p of 1. 1 square minus 5 into 1 plus 6. What do I get? 1 minus 5 plus 6. 2. P of 2 would be 2 square minus 5 into 2 plus 6. 4 minus 10 plus 6. Minus 6 plus 6, it's a 0. P of 3. 3 square minus 5 into 3 plus 6. What do I get? 9 minus 15 plus 6. P of 10. 10 square minus 5 into 10 plus 6. So I can see that out of the 4 given values, 2 values gave me the value of the polynomial as a 0. So I can safely say that out of the 4 given values, these 2 are the zeros of the polynomial. So what did we understand from this? We have understood that you have a polynomial. If you substitute any number in the place of x, we get a value for the polynomial. So if somebody asks you to find the value of this given polynomial at 3. Substitute x is equal to 3 in every part of the polynomial and get the value. Now we understood that if we are substituting a value and finally the value of the polynomial turns out to be a 0, that particular value of x is called as the 0 of the polynomial. Okay, fine. Okay. So we know how to substitute the value, a number in place of x in a polynomial. We know how to identify a number if it is a 0 or not by substituting the value. Suppose you are given a polynomial, any random polynomial, 3x plus 5. No value given, nothing given. They are asking you to find the 0 of this particular polynomial. They are telling you hx is a polynomial, 3x plus 5. Find the 0 of this polynomial. How do you find the 0 of this polynomial? We have to equate this particular polynomial to 0. Because that is finally the value of, the value of x at which the polynomial becomes a 0 is our root of the polynomial. So equate this to 0. So I get 3x is equal to minus 5 or x is equal to minus 5 by 3. So I can say that minus 5 by 3 is the 0 of this particular polynomial. This is a linear polynomial. Now how many zeros can a linear polynomial have? A linear polynomial can have only one 0. So quadratic polynomial can have 2 zeros. So in the previous example that we did, we saw that 2 and 3 were the zeros of the polynomial. So a cubic polynomial can have 3. So depending upon the degree of the polynomial, that many zeros a polynomial can have. So a biquadratic polynomial can have 4 zeros. Okay. Now let us find the 0 of the polynomial 9x minus 100. So you know that you have to equate the polynomial to a 0. Find the value of x. X is equal to 100 by 9. Clear?